Hi everyone. In this question we're going to be working on the 2014 AP Calculus free response question number 2. We're going to be using our graphic calculator, so if you happen to have it, take it out. Now what you'll notice about this question is you see two functions on the graph and you see a capital R. Chances are they're going to be asking you to find the area and potentially the volume when you rotate around a certain axis or a certain number. So when you see this question, you don't freak out because this is simple. It's all about being able to understand the formulas that you have to work with in order to actually solve this. It says, let R be the region enclosed by the graph of f of x and the horizontal line y equals 4, as shown in the figure above. Part A says, find the volume of the solid generated when R is rotated about the horizontal line y equals to -2. Well, you have to look for keywords. My first keyword was volume. My second keyword was rotated about y equals to -2. So that means that I'm taking this region and I'm going to rotate it as fast as I can around y equals to -2. So I'm going to put where -2 is, I'm going to put a horizontal line. So I'm taking this figure and I'm rotating it around here as fast as I really can. So something like that. Now when I do that, you'll notice that this region is going to come over here, but also all this stuff that's in between these points. So when you have that, you have to memorize the formula when it deals with volume around a certain point, around a certain line. It's A to B and a pi in the front. And what I usually call, what I consider this is total volume minus empty space. That's the formula to figure this out. So what we're going to do is we're going to find this total volume. But the problem is that you'll notice there's an A and a B. Well, how do I find this A and B? A and B are where these lines intersect. So what that means is I have to graph this equation. So I'm going to go to my y equals 2, type in both equations, x raised to the 4th minus 2.3 x to the 3rd plus 4, and then I'm going to type in on the other line y equals to 4. Graph it, and it'll graph something like that. Now, I'm zoomed out. I'm not as zoomed in as the actual question that appears on the paper. So what I'm going to do is I'm going to hit the zoom button. Number 2 where it says zoom in, click on zoom in. Just get between the graphs, so just move it somewhere in between. In the middle, press enter, and you should see what you're looking at on your paper. Now my goal is to see where they intersect, and I know they intersect here at x equals 0, but I don't know this value. Because I don't know this value, the only way to figure that out is using the button second in calc, intersect number 5, where it's going to say first curve. And what I'm going to do for first curve is I'm going to just get underneath that intersection, and then second curve I'm going to get to the right of it, so I'm kind of like trapping that in the middle. Press, when it says guess, press enter, and it should give you 2.3. So now I know the points where they intersect. A is going to equal to 0 because it intersects at x equals 0, and then B is going to equal to 2.3. So those are the points where it intersects. So that's perfect. So that means I'm trying to find all this volume all inside here when I rotate it about this line. So what we have to figure out next is, well, total volume is when I rotate this as fast as I possibly can, I'm going to get this entire space right here, all of this. So what I have to do is I have to figure out the equation for that. Well, I know that it's going to be pi, parentheses, A, which is 0, B, which is 2.3, minus my total volume. Total volume is all of this inside. What I normally do sometimes, I like to draw a rectangle to everything I'm finding. And the reason why I do that is because if you look at the top of the rectangle, that equation corresponds to 4. So it's going to be 4 minus my bottom equation, because the bottom of the rectangle is such in this equation, which is -2. So once again, when I'm finding total volume, I draw a rectangle so I can figure out what is the top equation minus my lower equation. Because to find total volume empty space, it's going to be top curve minus bottom curve, top curve minus bottom curve. And when top curve is y equals 4, bottom curve is -2. But the problem is I'm finding volume, this is area, so I have to square it. minus my empty space. Well, empty space is the stuff that I don't need. I don't need any of this volume. what I'm looking for is only this equation right here, this area or this volume. So what I need to do is I need to subtract all of this stuff I don't need. So then I'm going to draw another rectangle. And then ask yourself, what is the top of that rectangle touching? And hopefully you agree that it's f of x minus, what is the bottom one touching? -2. And then at the end you got to square it dx. And that's how you figure out the volume. Then your next step is, well, just plug into your calculator. So you're going to go to back to your home page, math. When you scroll down all the way to number 9, it says integral. But the only thing I was missing in the beginning was I was missing that pi. So you want to put second in pi and type exactly what you had on the paper. So math number 9, 0 to 2.3. And then it's all about being careful with the parentheses. So parentheses 4 plus 2, because negative is 2, squared minus top curve minus bottom curve, which happens to be x to the 4th minus 2.3 x to the 3rd plus 4 minus 2, which is again once more plus 2, close parentheses, then square it, and then just make sure you put a dx, let it calculate it for you, and you should get 98.867, and then always round to 4 decimal places. So your volume is going to be 98.8679. That is the volume when you rotate this region about the line y equals to -2. So once again, when you're finding volume, graph the line that you're rotating around. And what I always do is I always draw a rectangle so I can figure out the top curve minus bottom curve to figure out total volume, minus top curve minus bottom curve to figure out the empty space. And then don't forget the square and the pi on the outside. And that's part A. Then the next thing is we're going to work on part B. So working in part B, you're going to realize that it says region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. Well, all about keywords. What am I looking for to know that I'm going to do this process? R is the base of the solid. Whenever you see cross-section perpendicular, and then they're going to give you a shape. In this shape, they tell you it's isosceles right triangle. Then it's going to say find the volume. But my key word is always cross-section. Now, cross-section is pretty much when you take something and you cut it in between. Meaning, like, let's say I had a cylinder, and I were to cut it right in the middle. Well, when I cut it in the middle, it's going to give me a smaller cylinder. And when you look on top of the cylinder from up to down, you're going to see the same exact shape as you have on the bottom, because your base tells the shape when you have a cross section. So that's why they're going to tell you that the cross section is perpendicular to the x-axis, meaning everything is with respect to x, and then the bottom that with this shape appears is an isosceles right triangle. So then you go, okay, well, I want to find the volume. So I know to find the volume, it's AB, but it's not pi in the front. That's the biggest misconception when students work on this problem on the AP exam. They put a pi because they think volume for like part A, but that's only when you rotate it. We're not rotating anything in part B. We're just finding the volume of a base. So then once we figure this out, A to B, and what I want you to memorize is what type of shape do you have? You have an isosceles right triangle, which looks like that. Isosceles meaning both legs are equal to each other. And they told you that the region R is a base, so this right here is my base, region R. Well, how do you figure out the area of this equation? Half times base times height. Problem is, the base and the height are equal to each other, and they're telling you that the base is the region R. So that's like saying half times R, which is the same thing as saying half times R squared. Well, what is this R that we keep referring to? Well, we already found region R. We sort of found region R. Region R is the area that's found inside this shape. Well, how do you figure out the area that's inside the shape? So you're going to go A to B, top curve minus bottom curve. That's how you find the area that in between the region. So then what I'm going to do is, well, I already know that it intersects at 0 all the way to 2.3. And I myself, what is my top curve of this equation right here? Well, if you look at it, your top curve is y equals to 4, so it's going to be 4 minus f of x, which is that equation. Now, that's your area of your base, but the problem is we're doing an isosceles right triangle where the base is this area. So because of that, I'm actually multiplying it by half times 4 minus f of x, again dx, and that's the equation to the volume of the cross-section. Because it's an isosceles right triangle and the region R, the base, is always your area. And to give you a hint, every year if you look at it, the base is always given to you. So the base is usually going to be what you find, and then the height is always going to be a reflection of whatever the base is. So since they told you that isosceles right, the base and the height were the same, so that meant they were both equal to each other. So another way of simplifying this is as 1/2 0 to 2.3 4 minus f of x squared dx. And then what you're going to do is you're just going to type this into your calculator. So you're going to come back over here, 1/2 math number 9 0 to 2.3, and then parentheses 4 minus f of x, which was x to the 4th minus 2.3 x to the 3rd plus 4, close the parentheses, then don't forget to square it, because base times height in isosceles right triangle. This is a region of just R, and base times height, you gotta multiply them together. dx, press enter. Now the biggest mistake that let me actually type that in one more time. So when you go to math, 1/2 number 9 0 to 2.3, then once again 4 minus, and then I'm going to keep this in parentheses, 4 minus, and then I got to open up another parenthesis. That's what I forgot to do in the last one. I forgot to distribute the negative to the f of x. So 4 minus x to the 4th minus 2.3x to the 3rd plus 4, close the parentheses and close it again, and then second power dx. Then it'll give me my volume of 3.573, which is my answer. So that means that the base, when the volume of the base when it's a right triangle, or a isosceles right triangle, is going to be 3.5737. And that's your answer. So going through this one more time. When they ask you for a cross-section perpendicular to the base, all you're going to do is you're going to find the region R, the base, which they're going to give to you. They gave to you. They told you the base was the region R, which is top curve minus bottom curve, 4 minus f of x. So the next thing you got to figure out, well, what's my height? Well, if my base and my height are equal to each other, it's half times base times height. Multiply the base and the height together, which is this region times this region, which is region squared, times half because of the triangle. Plug into your equation using the integral formula, and then that's your equation. And then make sure you plug into your calculator right. So going to part C. Part C says the vertical line x equals k divides R into two regions with equal areas. Write but do not solve an equation involving an integral expression whose solutions give the value k. So what that means is you're taking this area and you're going to find a line x equals k, which is some line here, x equals k, that splits this area that's in here in half. Well, you have to remember, okay, so if I'm going to find where this k is equal to that cuts this in half, that means I'm going from 0 to k, then k to 2.3. So then that's an integral, that's area, because I'm trying to find two equal areas, which would be 0 to k of top curve minus bottom curve, 4 minus f of x, which is equal to, well, this 0 to k should be equal to k to this number, k to 2.3 of top curve minus bottom curve once again. And that's my answer. Because they're looking for a k value between somewhere between 0 to 2.3 that's going to cut this in half so they have equal areas. So the only way you can find that out, because area equation is integral, 0 to this k, split up from this k to 2.3, top curve minus bottom curve, because those are the areas of your formula. And that's it for part C. So for this question, you're going to get asked for volume. And you got to remember, total volume minus empty space, top curve minus bottom curve, top curve minus bottom curve. Then for part B, it asks you for a cross section. Remember, cross section, they're going to tell you your shape. Whatever the shape is, figure out how to find the area of that, which is half times base times height. Because they told you the base was region R, and base and height are equal to each other, region R times region R, which was half times region R squared, except you had to put an integral next to it, from A to B, dx. And then part C, it's telling you that it's going to divide, there's a certain k that's going to divide this into the two equal areas. 0 to k, k to 2.3, and top curve minus bottom curve for both equations. Okay? Hope to help. Thanks for watching.